Okay, so here's number 111. You have Earth, and then here's Earth. Here's a satellite that goes around, right, rotates around the Earth. The radius of Earth is 6,378 kilometers, and this satellite is 1,250 kilometers away from Earth. And you also know that the satellite does one complete revolution in 110 minutes. Here's a formula that connects linear velocity with angular velocity, and this is the radius. And they're asking for the linear velocity of the satellite. Okay? So we are going to first convert this revolutions per minute into omega. So 1 rev over 110 minutes times 1 revolution is 2 pi radians. So revolution is cancelled. So now I've got, you can reduce it if you want or leave it like it is, 2 pi radians over 110 minutes. So this is omega. Okay? So all you need to do now is multiply r, the radius. Now be careful because initially I made this mistake myself. When you get the radius, we're looking for the radius of the satellite, right? So it's actually, here's the center. This would be the radius because it's going around here. So the radius that we're going to use is this one, which is the radius of the Earth plus the radius here, the distance here. So together, so right here you have the sum of the two, and this is what you have. So velocity is the radius, and it's in kilometers. And then the omega is 2 pi radians over 110 minutes. And remember, radians is unitless number, so this one is not going to show up in the final answer. So you multiply 7,628 times 2 pi divided by 110. So it didn't ask us for a specific unit, so we're going to leave it at that, 435 kilometers per minute. Okay, so here's number 112. It has, let's see, the blade of a saw. Diameter is 7¼ inches, so that means the radius is 3.625 inches. It rotates at 4,800 revolutions per minute. And here we have the formula for that we're going to be using for these problems. And for part A, we want omega in radians per minute. So here I have revolutions per minute. So I'm going to multiply 1 revolution over 2 pi radians. Revolution is cancelled. So I'm left with 9,600 pi radians per minute. And that's the units they want. That's the units that are being asked for here. So this is the answer for part A. For part B, okay, so the formula that we're going to use for B is right here, because we have omega, which is this, and we have the radius, which is this. And they want the units in inches per minute, so here's inches, here's minutes. Okay, so we just set it up. So you multiply radius times angular velocity, and you get 109,327.4 inches per minute. Minute. Now remember, radian is unitless, so it's not part of the answer. So here it is. So 113 and 112 are very similar. They gave you the revolutions per minute of this wheel. You have the radius because they gave you the diameter. So we're going to convert this revolution per minute to radian per minute, because for part A they want angular velocity or angular speed. So we're going to do 1 rev, 2 pi radians. So for part A, I went ahead and multiplied these two. Remember, well, here we cancel revolution, so we're left with radian per minute. So this would be the angular velocity, so that would be the one here. for B, they want linear velocity, so they want V in inches per minute. So let's set that up. So when you put this into the calculator, and remember radian is unitless, so we are not going to, that's not going to be part of our answer. It's inches per minute, our units. So 64,324.1 inches per minute. And that would be the answer here. So for 114, they want the linear velocity in miles per hour, the road speed, which is the linear velocity. And so we have the rotations, 480, did I write it right? Yeah, 480 revolutions per minute. So this is going to give us the angular velocity. It's going to give us omega. So I'm going to convert it to 1 revolution is 2 pi radians. Okay, so revolution and revolution cancel, and so that gives you 960 pi radians per minute. Okay, so for velocity, it's r times omega, so we're going to multiply 12.5 inches times 960 pi radians per minute times, now we don't want inches per minute, we need miles per hour, so I'm going to convert the minutes to hours. So 60 minutes is 1 hour, so minutes cancel minutes, and then 12 inches, I'm going to convert inches to miles, is 1 foot, so inches and inches cancel. And then, let's see if I can fit a little bit more. No, it doesn't move. Well, I'll squeeze it here. 5,280 feet for 1 mile. So feet and feet cancel. So now we have the units we need. We have miles right here, hour right here. And remember, this is unitless, so this does not go into the final answer. So take your calculator and put all these numbers. So for part B, they ask you to find how fast, let's see, the rate at which the spin balance machine should be set to test for 70 miles per hour. So we're looking for how many revolutions per minute would you need to test for 70 miles per hour. So here's the equation, V equals R omega right here. So I need to solve for omega so that I can get to this. Okay, although this and this are not the same, but once you have this, you can get to this. Okay, so I'm solving for it. So I'm dividing both sides by r, and so this is canceled. So V over r equals omega. So V over r. So I'm going to write it again right here. So 70 miles per hour. That's V. Over r, the radius is 12.5 inches. I'm going to convert miles to inches so I can cancel that unit. So 1 mile, 5,280 feet, and so that cancels mile. 1 foot, 12 inches. Foot cancels foot. And now I can cancel inch with inch, okay? So I need to change that hour to minutes. So 1 hour, 60 minutes, and so hour cancels hour. So what we have now is, notice the numerator has no, like right here, no units are left, right? No units, they're all canceled. Well, that's because omega is radians per minute, and remember radians is unitless. That's why there's no units left up here. So take your calculator and input all these numbers. So now we get this as the omega. So now to get revolutions per minute, we just have to multiply, and let me write it here a little bit on this, more to the left. 5,913.6 radians per minute. So there are 2 pi radians for 1 revolution. So radian and radian cancels. And now we have what we need, revolutions per minute. So just divide that number by 2 pi. Okay, so you get 941.2 RPM. So that's what you would put here. So we need angular velocity in radians per second. We have the radius right here, 6 centimeters, and we have how many revolutions per minute. So I'm going to convert this. 1 revolution is 2 pi radians. So revolution cancels. And then minute, I've got to convert to seconds. So 1 minute, 60 seconds. And so put this into a calculator. So here you have the answer. Again, for angular velocity, we usually keep it in terms of pi. So that's why you see it as 1,000 pi over 3 radian per second instead of a decimal. Okay. Okay, so for part B, they want the linear velocity. And remember the formula is this one up here. Radius times angular velocity. So the radius is 6 centimeters. And then the angular velocity is 1,000 pi over 3 radians per second. Now, the answer needs to be in meters per second, not centimeters per second. So we got to convert. There are 100 centimeters in 1 meter. So 100 centimeters in 1 meter. So centimeters are canceled. And so I can reduce 100 here and 100 here, and then 3 here and 2 here. So you're left with 20 pi meters per second, so you just have to multiply it out. So you multiply 20 times pi and you get 62.8 meters per second. Okay, so first thing you want to verify that this is a unit circle. So you take each of the coordinates x and y and multiply and square them. And remember, this is we could form a right triangle right here if you draw the line vertical to the perpendicular to the x-axis. So you'd have a right triangle right here with the right angle being right here. And so this is like this is a Pythagorean theorem, a squared plus b squared, and you want to see what it equals. It equals 1, and you take the square root of 1 and it's 1. So that tells you that the radius is 1. This is a unit circle. With that in mind, it's asking you to give the 6 trig function values for that angle. So you have sine of theta is the y-coordinate, cosine of theta is the x-coordinate, 4/5, tangent of theta is y over x, and so it's going to be negative 3/5 over negative 4/5, so it's positive 3/4. And then the reciprocals, you just flip the numbers, secant and cotangent. And that's the answer for that. Okay, so 69 and 70, I just drew a really rough sketch of the unit circle, but you could look at your book for a nicer picture, okay? A more accurate one, actually. So for 69a, sine of 5, remember sine on a unit circle, sine is the y-coordinate, okay? So sine 5, here's 5 radians, and this is my y-axis. So if I go straight across right here, straight across, I want to see this distance, right? So this is approximately negative 0.94 or 5, around there. Okay, and then you take a calculator to test it out, and I'll do that in a minute. First, let me do the approximations. And then for cosine of 2, here's 2 right here. Now remember, cosine on a unit circle is the x-coordinate. So the x-coordinate, you would drop a line straight down here and see where this lands, right here. So I'd say it's about negative 0.4. Okay, so I'd say it's about negative 0.4. Okay, so for sine of 0.75, It's right here, and so we're going to go across this way to see this